Reflow soldering is a process in which a solder paste is used to temporarily attach one or several electrical components to their contact pads, after which the entire assembly is subjected to controlled heat, which melts the solder, permanently connecting the joint. Heating may be accomplished by passing the assembly through a reflow oven or under an infrared lamp or by soldering individual joints with a hot air pencil. Reflow soldering is the most common method of attaching surface mount components to a circuit board, although it can also be used for through-hole components by filling the holes with solder paste and inserting the component leads through the paste. Because wave soldering can be simpler and cheaper, reflow is not generally used on pure through-hole boards. When used on boards containing a mix of SMT and THT components, through-hole reflow allows the wave soldering step to be eliminated from the assembly process, potentially reducing assembly costs. The goal of the reflow process is to melt the solder and heat the adjoining surfaces, without overheating and damaging the electrical components. In the conventional reflow soldering process, there are usually 4 stages, called zones, each having a distinct thermal profile: preheat, thermal soak, reflow, and cooling. Preheat zone, maximum slope is a temperature-time relationship that measures how fast the temperature on the printed circuit board changes. The preheat zone is often the lengthiest of the zones and often establishes the ramp rate. The ramp operate is usually somewhere between 1.0 degrees Celsius and 3.0 degrees Celsius per second, often falling between 2.0 degrees Celsius and 3.0 degrees Celsius per second. If the rate exceeds the maximum slope, damage to components from thermal shock or cracking can occur. Solder paste can also have a spattering effect. The preheat section is where the solvent in the paste begins to evaporate, and if the rise rate is too low, evaporation of flux volatiles is incomplete. Thermal soak zone, the second section, thermal soak, is typically a 60 to 120 second exposure for removal of solder paste volatiles and activation of the fluxes, where the flux components begin oxide reduction on component leads and pads. Too high a temperature can lead to solder spattering or balling as well as oxidation of the paste, the attachment pads and the component terminations. Similarly, fluxes may not fully activate if the temperature is too low. At the end of the soak zone, a thermal equilibrium of the entire assembly is desired just before the reflow zone. A soak profile is suggested to decrease any delta T between components of varying sizes or if the PCB assembly is very large. A soak profile is also recommended to diminish voiding in area array type packages. Reflow zone, the third section, the reflow zone, is also referred to as the overtime above reflow or overtime above liquidus and is the part of the process where the maximum temperature is reached. An important consideration is peak temperature, which is the maximum allowable temperature of the entire process. A common peak temperature is 20–40 degrees Celsius above liquidus. This limit is determined by the component on the assembly with the lowest tolerance for high temperatures. A standard guideline is to subtract 5 degrees Celsius from the maximum temperature that the most vulnerable component can sustain to arrive at the maximum temperature for process. It is important to monitor the process temperature to keep it from exceeding this limit. Additionally, high temperatures may cause damage to the internal dies of SMT components as well as foster intermetallic growth. Conversely, a temperature that is an unregistered trademark T hot enough may prevent the paste from reflowing adequately. Time above liquidus, or time above reflow, measures how long the solder is a liquid. The flux reduces surface tension at the juncture of the metals to accomplish metallurgical bonding, allowing the individual solder powder spheres to combine. If the profile time exceeds the manufacturer unregistered trademark S specification, the result may be premature flux activation or consumption, effectively edging the paste before formation of the solder joint. An insufficient time-temperature relationship causes a decrease in the flux unregistered trademark S cleaning action, resulting in poor wetting, inadequate removal of the solvent and flux, and possibly defective solder joints. Experts usually recommend the shortest TAL possible, however, Most pastes specify a minimum TAL of 30 seconds, although there appears to be no clear reason for that specific time. One possibility is that there are places on the PCB that are not measured during profiling, and therefore, setting the minimum allowable time to 30 seconds reduces the chances of an unmeasured area not reflowing. A high minimum reflow time also provides a margin of safety against oven temperature changes. The wetting time ideally stays below 60 seconds above liquiders. Additional time above liquiders may cause excessive intermetallic growth, which can lead to joint brittleness. The board and components may also be damaged at extended times over liquiders, and most components have a well-defined time limit for how long they may be exposed to temperatures over a given maximum. Too little time above liquiders may trap solvents and flux and create the potential for cold or dull joints as well as solder voids. Cooling zone. The last zone is a cooling zone to gradually cool the processed board and solidify the solder joints. Proper cooling inhibits excess intermetallic formation or thermal shock to the components. Typical temperatures in the cooling zone range from 30°-100 degrees Celsius. A fast cooling rate is chosen to create a fine-grained structure that is most mechanically sound. Unlike the maximum ramp-up rate, the ramp-down rate is often ignored. It may be that the ramp rate is less critical above certain temperatures, however, the maximum allowable slope for any component should apply whether the component is heating up or cooling down. A cooling rate of 4 degrees Celsius is commonly suggested. It is a parameter to consider when analyzing process results. Etymology: the term reflow is used to refer to the temperature above which a solid mass of solder alloy is certain to melt. If cooled below this temperature, the solder will not flow. Warmed above it once more, the solder will flow again, hence reflow. Modern circuit assembly techniques that use reflow soldering do not necessarily allow the solder to flow more than once. They guarantee that the granulated solder contained in the solder paste surpasses the reflow temperature of the solder involved. Thermal profiling. Thermal profiling is the act of measuring several points on a circuit board to determine the thermal excursion it takes through the soldering process. In the electronics manufacturing industry, SPC helps determine if the process is in control, measured against the reflow parameters defined by the soldering technologies and component requirements. See also, wave soldering, reflow oven, restriction of hazardous substances directive, thermal profiling. References